Now we'll continue with question 2. It's a 5-mark question on volume of revolution. The question says that the region bounded by the curve, the x-axis, in the line x goes to 0 and x goes to pi is rotated by 2 pi radius about the x-axis. Now, I want you to pay attention to the word x-axis because when the question says x-axis, you don't have a choice. Ladies and gentlemen, you don't have a choice. When you say x-axis means it's legit x-axis, they want you to go and integrate with respect to x. So, if any of you in this paper have tried to integrate with respect to y, we are going to straight away get 0 marks out of 5 because the question is directing you to integrate with respect to x. So, based on hardcore content, you should be using the formula pi integrate y square with respect to x, where y is the function. Now, y is the function x root sine x. So, it's supposed to integrate x root sine x whole thing square with respect to x. And as you can see, the upper limit is going to be x equals to pi, while the lower limit is going to be x equals to 0. In case you cannot visualize, right, the best thing to do in this topic is to use a GC. So I'm going to use my GC online and I'm going to show you how exactly to do it. I'm going to switch to my GC now. Please give me a moment. Okay, so now I'm at my GC and what I'm going to do is to go and sketch the curve of x root sine x such that I can tell whether the area bounded by the curve is a positive or a negative value. So I'm going to key in the equation of the curve now. Then I press graph. When I press graph, what you're going to notice is that it's actually quite a broken graph, you notice, because so it probably looks like a piecewise, no, sorry, it's not a piecewise function because there are some values of x for which the function is going to be rendered invalid. Okay, so like for instance, you cannot square root a negative number, so that is going to render the graph invalid. So what I'm going to do now, right, is I'm going to force the GC to go and zoom in between 0 and pi. Why? Because they want the area bounded by x equals to 0 and x equals to pi. So what I'm going to do is go to my window. I'm going to adjust the x minimum to be 0. And I'm going to adjust the x maximum to be pi. Now what I'm going to do is to press enter, and after that I'm going to press graph. Oops, maybe the square scale is a bit too big, so I'm going to like what I call condense it. So I will change the settings of y also. Maybe this one can be -1, while this one can be maybe I try 3. Okay, then press enter. Down, you see a beautiful graph comes out over here, right? But then you see that at the right at my cursor here, right? The graph does not completely go like the graph just end off somewhere there, right? So, but do you know whether the graph actually ends out like that? Sometimes not necessary. It can be because of the GC error itself. So, in this case, what you need to do is to go and force the GC, right? I'm going to force the GC that I paid $200 for to go and do the best it can for me. So what I'm going to do is I'm going to press calculate. I'm going to press calculate because it doesn't extend to the part whereby the x equals to pi. So I'm going to press calculate and then I'll calculate a value of y when x is equals to pi. So if I press enter, you'll notice that here it says y is equals to 0, which means that by right, the graph should be stretching all the way to 0, right? And then for the rest of the domains that goes beyond x equals to 0 and x equals to pi, you'll notice that this function is invalid simply because sine x will be invalid. You cannot square root the sine x will be negative. You cannot square root a negative number, right? Okay, so now I'm going to go here back to my original screen, right? So I hope I'm sharing the GC. I'm going to go back to my original screen, and then after that, so as what I can see here, right? As what I can see here, when x equals to 0, y equals to 0, I've calculated the lower limits and at the upper limits as well. So the area that you want to integrate is going to be the pink color thick region, and because this area is above the x-axis, so you are expecting the definite integral to be positive. Which also means that because you're expecting the definite integral to be positive, you don't necessarily have to what you call go and do a modulus or to go and change the signs. Okay, now, so because I have the GC already, what I'm going to do is I'm going to show you the answers for question 2. So, again, CSTE. Ladies and gentlemen, hardcore content. Time to recall hardcore content. Volume of revolution only has two formulas. Number one, pi integrate x squared, definite integral with respect to y. This is when it is bounded by the y-axis. Pi definite integral of y squared with respect to x. This is when you are integrating the volume by the x-axis, bounded by the x-axis. And moreover, the question will tell you, because in volume of revolution, it is a new concept, right? So because when you rotate about the x-axis and you rotate about the y-axis, right, the volume generated is going to be different. So the question is going to tell you, please keep a lookout. Here, the question tells you x-axis. Hardcore content knowledge will tell you pi equate y squared dx. So I basically substituted y in equation of curve y, and then you notice that I can actually simplify it. So that when I simplify it, it is x squared sine x, definite integral with respect to x. And then of course, please remember to times a pi. So okay, so I reached the third step, right? But you notice that from the third step onwards, right? It is like that is when your integration techniques start to come into play. If, ladies and gentlemen, please memorize your techniques. If you don't memorize the techniques for integration, right, then the applications will also be hard because you can't even do the integration techniques itself, right? Okay, so now you see, sine x is a trigonometric function. X squared is an algebraic function. So because these functions are of different types, and moreover, they are two separate functions, what you are going to have to do is that you are going to integrate this by parts. By parts integration, okay? So when it comes to by parts integration, you are going to have a fill up a template, right? You're going to ask yourself in your head, now which one to integrate, which one to differentiate, right? And surely you all have heard of this acronym LIATE, where logarithmic function is the first priority to be differentiated because the logarithmic function is not integrable but very easily differentiable, right? So when you differentiate logarithmic, so now if you follow this order, you have to differentiate the algebraic function first. But why do I choose to differentiate the algebraic function and integrate the trigonometric sine x? The reason is because here is an x squared. If you differentiate it sufficiently number of times, you notice that it is going to yield you a constant. Okay, it's going to yield a constant. And in fact, if you try to differentiate this twice, if you don't believe me, try to differentiate this twice. Find d2y dx squared if y is equal to x squared. But that being aside, so okay, I filled out the templates. U equals to x squared. Differentiating it, I'll get 2x. And same for dv, right? dv dx is sine x, right? And so I integrate this, I'm going to get negative cosine x. Please remember to put the negative sign, okay? Then after that, I also want to talk about this. After you finish right here, I'm going to fill up the by parts templates ready. So uv minus v du. U dv integrates u then I've got differentiate v dx with respect x, all these formulas. So this formula says, right? This formula says that basically uv minus v du. U is the original u function, so we have fill in x squared. V is the integrated function of dv dx, right? So I'm going to have negative cos x, right? Then minus away definite integral of pi, and then the lower limit is 0. Then then the formula says it should be v du. So what is v? Negative cos x. Du means you differentiated u already. So they're asking for du dx. So it is the du dx. It is supposed to be 2x, right? And hence I end up with negative 2x cosine x with respect to x, right? And of course, of the constant pi, don't forget about it. Then Because you see negative, negative, I can actually simplify it, factor out the constant, is going to be a positive. So it's going to be a plus 5. Integrate 2x cosine x with respect to x definite equals. And that's when you notice that, oh, okay, it's still an algebraic and a trivial function. And that is when this is the trigger. It triggers your mind to do a bypass again. Why do you do a bypass again? Because you want to go and simplify it into a standard form, right? It's not simplify into a standard form. So you notice that here, after I go and differentiate the 2x, right, u equals 2x, du dx equals to 2. Do you notice that u dx is a constant already? And because it's a constant, right, based on your integration techniques, you remember they can always factor out the constant, right? And then, moreover, dv dx equals to cos x, you integrate it back, you're going to get sine x, right? So because you are going to get back sine x, right, you are going to notice that, oh, okay, here, what I can do is, I can just go and write pi, then that I'm going to have uv minus v du, right? I'm going to have uv minus v du. So, uh, u is 2x, v is sine x, so 2x sine x, as you can see in this highlighted part over here, x sine x, and then after that, uh, minus pi, then this is v is sine x, u is 2, so 2 sine x dx, right, respect to x, and then you notice that, oh, okay, now it just becomes a simple integration of sine x. Why? Because I factored the constant 2 out. So after the integration, I'm going to get to this line over here. I'm going to get this to this line over here, and after that, I'm going to, and after that, the what comes after this, right, is just simplifying the integral. So the moment I simplify the integral, what I'm going to get is this line over here. And then from this line, what I need to do is to substitute in the limits. Substitute in the limits shouldn't be that confusing for you, because after you substitute in the limits, you all need to do is just to remember to multiply by pi. And the moment you multiply by pi, you notice you're going to get this answer over here. So this answer over here is my final answer. Okay. So, ladies and gentlemen, what is the learning point from this question? Hardcore content. When you integrate and find volume of revolution for definite integrals, right? Only two formulas. Question and television. Standard forms and integration tag. If you don't know your standard forms, you can't even do this. So this is called hardcore content. What it is the skill? The skill is to decide which function to differentiate and which function to integrate based on LIATE. And be better still, like roughly know why. Why do you want to go and differentiate the algebraic function? Why do you want to integrate the trigonometric function? Right? Then, of course, the technique here is going to be pi parts twice. Why did I select this technique? Because it is separable functions. And moreover, they are not related by f prime and f. And because they are not related by f prime and f, what I'm going to do, right, is that I'm going to use the by parts formula to go and separate them, one to differentiate, one to integrate, right? And my advice for you is that if let's say you are very weak at by parts integration, you cannot tell which to choose, you must then you go and fill up the four functions template. Okay, it's called the 4 functions 2x2 template. U, du on one column, then dv, dx, and v on another column. So I call it the 2x2 4 functions template. Okay, like for instance, u equals to x, du dx equals to 2, dv dx equals to cos x, v equals to integrate cosine x with respect to x, so it's sine x. See, so I want to say that this template over here is very useful. If let's say your integration techniques on by parts is very weak, this template, this template here, is very, very useful. Yeah, this one, very, very useful. Okay. Then, if time permits, right, you are going to have to check your work using a calculator to ensure that this is correct, right? So, if you have to see this, right, you have to see this over here, right? Okay, so what I basically did, right, was I went here, and then after that, I keyed in my answer on the numerator and divided it by pi. Why? Because later on, I'm going to cross-check the GC. It's easier to divide by pi because when you find the volume of revolution, you are supposed to multiply by pi, right? You are supposed to multiply by pi. But then again, the GC cannot find a definite volume revolution for you. It can only find the definite integral of area under the curve. So what I treated it was like a definite integral of y squared with respect to x without the pi inside, and that is the reason why I divided by pi. And moreover, when I checked in the GC, have you noticed that this one, right? I actually on the y1, right? I actually plotted this thing called y squared. So I'm going to integrate y squared with respect to x. With respect to x, right? Yeah. So I'm going to integrate this with respect to x. And after that, I'm going to key in the limit here. So this one is going to be, this one is going to be pi, right? This one is going to be pi. Give me a while. So this one is going to be pi, this one is going to be 0, right? So so this definite integral is I'm going to calculate using the GC, right? And because after I calculated definite integral using the GC, by the way, you all know how to go and use definite integrals. If not, let me show you. Okay, let me demonstrate. Okay, so I'm going to go back to my GC. I'm going to back to my GC. What I'm going to do now is that I'm going to key in the equation for y squared. I'm going to key in the equation for y squared. In a while, I'm going to key in the equation of y squared such that it is a systematic way to check what, because the point of evolution says y squared with respect to x. Okay, so I'm going to plot the graph. After I plot the graph, C is still within the window of 0 to pi domain. So I can very simply go and calculate and then go all the way to 7, press 7, right? Then the lower limit, just press, okay, you don't necessarily have to shift the points. If you want exact form, just press the exact number that you want. For instance, I want the lower limit x equals 0. I just click 0 here. And then after that, I press enter. See? Upper limit x equals 0, y equals 0. Well done. Now, second pi for upper limit. I'm going to ask for upper limit, right? So x equals to pi. The upper limit is going to be pi. And because you see now they integrate it for you, right? They integrate it for you. And they show you that this is actually 5.869604 for whatever string of decimals that may be. I don't care. Because what I'm caring about is whether does this definite integral over here correspond to the value in my calculator over here. Because if it just corresponds, then my answer is correct. Because all I need to do is to multiply by pi when I'm trying to find the volume of revolution. And that is the reason why I integrate definite integral y squared with respect to x into the GC and not, I say it again, and not y. It has to be y squared. Okay, so you can see here my answer over here tallies with the answer given in this GC. And because of this, my answer is correct. Okay. That's all for question 2. Question 3 in our video. Bye bye.